Let me check on you guys in Zoom one more time. He's already in here, so I'm just gonna let it ride. Let me share my screen. Start the broadcast. Okay, and we'll start here for right now. All right, scholars. Let me see. Let me pull up my calendar, which is here. All right, so happy holidays, everyone. Welcome. We are essentially in the home stretch, right? The last day of class is this Wednesday, right? So what that means, so here's a brief snapshot or synopsis of the remaining schedule. So we're gonna meet today. Today we'll take some time to review exam 2, right? So today and Wednesday are gonna be review in preparation for the final. So today we're gonna review exam 2, just go through as many questions, and we can, if you have questions from anything that you've been assigned, you can ask. If you're working on something, you can just ask and we can work on it together. But yeah, I'm just choosing exam 2. We don't have to do exam 2. But today, I'll focus on exam 2, and then Wednesday, which is the last day of class, last time that we're gonna meet, we'll work on exam 3. Thursday and Friday of this week is the reading period, so you shouldn't be meeting in any of your courses. And then, so your final exam should become available this Sunday. So almost in like 6 days, right? This Sunday at 11:11, and it'll be due the following Friday, December 9th, right? So I think the final is available from December 4th through December 9th, right? I know I had like 1 or 2 students asking me saying, they couldn't find the final. I was like, it's because it's not available yet, So it doesn't become available until this Sunday. Yes.
What did you say the dates for the exam were?
It's going to be available on Pearson from this upcoming Sunday, December 4th through, and it's going to be due the following Friday, December 9th at 11:59 p.m. So,
okay.
Yeah, it should become available, at 11:11 on that. Let me get these. Okay, I feel like he's good, so I'm going to let that be. Let me get these gentlemen. I need to hop over here. So here's 1. This 1, 2. Hey, Mr. Wilson. Right, this one. Cool. Okay. Yeah. So, if you're just joining us, welcome. Happy holidays. Hopefully, you enjoyed your, day of giving thanks. I don't know why they just choose a day. Why not give thanks every day? Why not? Anyway, I guess it would lose. It wouldn't be special or something. I don't know. But that's neither here nor there. Hopefully you were able to, enjoy yourself, position yourself for success, maximize your time with your loved ones, things of this nature. Get some rest, do what you needed to do so that you can, succeed. So again, today we're going to take some time and go through we're going to review exam 2. So anything related to exam 2. Wednesday, which is our last day of class, we'll take some time to review exam. Let's hop over here. We'll take some time and let me do this because I forgot. There it is. This helps as well. Yeah, that looks good. Okay. Wednesday, we'll take time to review exam 3. Again, also Wednesday is our last day of class. Thursday and Friday of this week is the reading period. And again, your final exam should become available this upcoming Sunday at 11:11 a.m. It's due the following Friday, December 9th at 11:59 p.m. Also, that Friday, December 9th is the hard deadline. So that means everything on Pearson is going to be due at that time, right? So nothing past that date, that time. The goal or idea is that when you submit your final exam, you should be done. You shouldn't have anything that you're trying to submit past that point. Okay, let me try rebooting. Let's see, because it doesn't look like it's connecting. Let me stop this and share the screen again. Start the broadcast. Is it live? Just trying to get my, okay, that looks better. Yeah, and then one other thing I need to mention is that, so during the week of finals, so basically next week on Monday and Wednesday, you're not so the last day I'm going to take attendance is this Wednesday. Next week, I'm just trying to figure out why this isn't showing. Because it's not showing there. So go like this. I'm not getting my confirmation. I don't know if you guys can see my screen or not. Like it should be a white screen, but I'm not getting my thing that says that it's working. Let me try rebooting this because sometimes that throws things on the fritz. Let me stop this one more time and try one more time. Let's see. Like it should be a white screen, but I'm not. Give me a second. I'm just trying to make it so that because for some reason the image doesn't get pushed. Let me stop this one more time. Try it one more time. See what happens this time. Like it should be, Give me a second. I'm just trying to make so that for some reason the image doesn't get pushed. Stop this one more time. Okay, that's there. I think it's just notability. Okay, that's looking better. All right, okay, that's looking better. Okay, yeah, so the final thing that I wanted to share was that during the week of finals again, so the last day I'm going to take attendance is this upcoming Wednesday, November 30th. So that's the last day that you're obligated to just check in to get your attendance. During the week of finals, you're not obligated to attend, but more than likely I'll be online during class time. More than likely on that Monday and Wednesday, I'll be online pretty much throughout the entire day from like, when you guys start at 9 o'clock until about 5 o'clock. Like I'll leave at 5 because I have a class that runs from 4 to 5. I might take a break around noon, but if you just check in periodically, if you're looking for me or you have questions or you need help with anything, again, so during the week of final, I should be available. Basically, it's essentially from 9 to 5 on that Monday and that Wednesday, okay? You're not obligated to attend at those times. The last day that I need to get your attendance is this upcoming Wednesday, and that's the long and short. So as usual, if you have questions about anything, feel free to unmute yourself. That's my recommendation to get my attendance. I'll check to get my attention. I'll check the attendance again at about the 15-minute mark in about 4 minutes. And let's go ahead and try to answer as many questions from exam 2 together as we can. Okay, so it says the functions f and g are given. So again, the intent or my goal is to use this exam to just start to kind of expand on some concepts, right? For instance, with this one, this is talking about combination of functions, adding, subtracting, multiplying, and dividing functions. And then the fifth concept of composition of functions, right? So remember this open circle. Let me see if I can zoom in, right? So this open circle, at first glance, students might be tempted to say, oh, that means f times g. Remember, this open circle does not mean multiplication. It means composition. It means the second function inside the first function, right? So we'll work an example or two highlighting that. That's the long and short of that concept that I really wanted to mention to just bring to people's attention. And so here it says the functions f and g are given. Evaluate f compose g and find the domain of the composite function f compose g. So there is a 3-part process that I use to find the domain of a composite function, okay? So again, the goal here, we're just trying to expand on as many concepts. You should be better than that because I've been charging you for some time. Let me see. Oh, you were bugging. Maybe you weren't charging. That sucks. Okay, let me try to charge it up some more. Use that charge. Okay. So we're asked to evaluate f compose g and find the domain of the composite function. Okay, so let's take some notes. Let me get a screen like this. Okay, cool. We're going to take it from here. This one, this, right there. I really like this update. I'm gonna hit done. I'm gonna hit copy and delete so that way I don't have a whole slew of unnecessary screenshots. And I'm gonna drop that copy here. Yes, allow the paste. Okay, so let's take some notes here. Okay, so we have f and g. First they asked us to find f compose g, so let's go ahead and do that. And then we'll talk about how to find the domain of a composite function, right? And like just for a little bit of encouragement, you know, no matter where you are at this moment in time, whatever grade, like up to like about an A minus, if you want anything from an A minus on down, you whatever grade you want, honestly, you can get it. You just got to make a plan, really. And it sounds simple, it's just not easy because you still got unlimited attempts. It's only a 10% late penalty. And so, like, again, just as a reminder, if you're trying to go back and improve your overall score, I would encourage you to prioritize your old exams. That's where you're going to get the most bang for your bucks. Those count for nearly 80% of your overall grade. Once your exams are wherever it is that you want them to be, then you know the last thing you want to prioritize is the homework because that's going to be a whole bunch of work for minimal points. And then also just make sure that you're collaborating with Dr. Lamar for the lab component of this course. Okay. So if you have questions about the lab, you do have to reach out to her because that's her domain. Okay. So now composition functions, right? F composed G, it just means the second function inside the first, right? So we have this F composed G of X, right? Now, when we write it like this just means the second function inside the first function. Sometimes what I see students do, they'll try distributing this X and it throws everything off. You don't want to do that, right? That's not what we're doing, right? Okay. So what this means, all this means is the second function, I'm going to do it in green, inside the first function. That's all that it means. Okay. So then from there, we can do F of, now what's our G? Our G is 5 minus 2x. So all we're going to do, we're going to write F of X like normal and replace each X in F of X with the green thing. Let me say that one more time. All we're doing here is writing F of X like normal, but we're replacing each X from F with the green thing, okay? So if we write F like normal, now when I do my substitution, I like to use parentheses. So I'm replacing X with the parentheses, or blank parentheses. And then now into the blank parentheses goes the green thing, right? Then from there, we're ready to simplify. We have it in the proper form. You know, we can account for everything that we need to account for. Right, so there's no distributing here. We can combine like terms. 5 minus 6 ends up being -1. So it looks like we have a -2x minus 1 inside the square root. Okay, so that's F composed G. Then they ask us to find the domain. So let's talk about how to find a domain of a composite function. So that again, the 3-step process. So I'll put it over here. Domain of composite, right? A composite function. Okay. There's a 3-step process. The first is you want to find the domain of the simplified function. Let me see. Sorry. First, find the domain of the inside function. Okay, so that's the first step. Second step is we want to find the domain of the simplified function. And in the third step, we're going to get 2 intervals. Like from the first step, we're going to get an interval. The second step, we're going to get an interval. The third step is we want to take their intersection. Okay. This 3-step process has not failed me when it comes to finding the domain of a composite function. This is just what's been working for me. So that's what I do, right? So if we're going to apply that to this one, so then we'll put it here and I'll just kind of work. So first we're going to find the domain of the inside function. Okay. And give me just a moment. In a little bit OCD here, copy. Paste. Okay. So our inside function is G. So if we look at G of X, if you think about this graph, it's just a straight line. It's a diagonal, right? The y-intercept is 5, okay? And it has a slope of -2. This is in the form of y equals mx plus b. You just have to rearrange it, all right? So it's just a diagonal line. So then if this is just a diagonal line, the domain of a diagonal line is all reals. So then I'm going to abbreviate like this: domain of g of x. In this case, it's going to be all reals. So negative infinity to infinity. Okay. So then the second part, now we want to find the domain of the simplified function. Okay. So the simplified is what we have in the box. Okay. So when it comes to square root, basically we cannot take the square root of negative numbers. So to find that domain, we need to take the radicand, which is this negative, negative 2x minus 1. That needs to be greater than or equal to 0. Again, we cannot take the even root or the square root of a negative number. So that radicand needs to be greater than or equal to 0. Okay. So then if we solve, if we multiply both sides by here, if we add 1, we'll get negative 2x is greater than or equal to 1. If we divide both sides by negative 2, right? Multiplying or dividing by a negative flips the inequality. So then we get x is strictly less than a negative 1/2. Okay. So that's the domain of the simplified. Let me highlight these guys. So here's the domain of the simplified function. Here's the domain of the inside function. And let me do one other thing. I'm going to just rewrite this into interval notation. So if x is less than or equal to 1/2, so if we think about the number line, if x is less than or equal to 1/2, are we talking about all the numbers on the left side of negative 1/2 or all the numbers on the right side, right? Are we talking about all the numbers smaller than negative 1/2 or the numbers bigger than negative 1/2? So if x is less than or equal to negative 1/2, we're talking about all the numbers to the left, right? All the numbers less than. So to capture that in interval notation, I guess I'm going through puberty again. My voice totally just cracked like I was in middle school. Today. So x is less than, so left of negative 1/2 is going to be negative infinity up to negative 1/2. Infinity always gets a parentheses, and because of the bar, we get a bracket. Okay. So that's the domain of the simplified function. I'm gonna just highlight it like that. Okay. So we have the domain of the inside function. We have the domain of the simplified function. So then the third step is we want to take their intersection. So the third and final step, we want to take their intersection. Okay. So then all reals, if we think about the entire real line, like all reals, intersection, half the line, what do these two sets have in common? The whole line compared to half the line. What do they have in common? Is that half of the line. Hopefully that makes sense. Okay. So then long story short, this is going to be the domain of our composite function. Okay. I know it's a bit much, but this is what it takes, right? This is what it is. I don't know a better way to do this. Some of this stuff, there's no way around it, right? You just have to do it. Now sometimes there are more sophisticated, more simple ways to go about it. If you discover it, I do ask that you run it past me. Sometimes I do borrow you guys' suggestions. One of my students, I used to always use the point slope, and then the students were like, well, we just use y equals mx equals b. And then I checked it, and it was correct. So I felt like their technique was more simple, so I borrowed it. So let's submit this information, negative 2x minus 1, and that. Okay, let's hop over here. So F compose G, we got, need this to go away, off, okay. So we got square root. Let's plug this in because I know the battery's low. We had negative 2x, nope, 2x minus 1. I'm going to check attendance. And then the domain we got was the half interval. So it was parentheses, negative infinity, nope, negative infinity up until, I think it was a negative 1/2, okay, and a square bracket. All right, so that's not trivial. All right, this is why we're having this to try to dust off some of the cobwebs. So if you know you're uncomfortable with this, this exam is from sections 1.4 to 1.6, right? So you might want to go back and review those sections, maybe redo some of the homework from those sections, maybe redo the quizzes a few times because the quizzes should change as well. Maybe redo this exam, sit down with the tutor or your classmate or somebody that gets this section, you know, and you might want to just kind of redo some of those. Let me check on you guys in Zoom. Okay, that looks good. Let me get the student. Chat J right here. So we're missing some people, but you know, we're all adults here. So if you haven't realized by now, the way I run my course, I treat you guys like adults. I know many of us are right out of high school, you know, so it's our first time on our own, but at some point, there has to be some kind of point in your life where you decide to take accountability for your experience, right? And this is like, to me, an adult thing is, you know, and not all people of age think this way or behave this way, but, you know, my personal philosophy is, if things are going wrong in my life, I don't have nobody else to blame but myself. I got to make some different choices. I got to choose things differently. If I don't like the outcome or the results or what I'm experiencing, I can blame my parents, girlfriend, children, you know, I can blame whoever I want, but it doesn't fix anything, right? The adult thing is I got to be accountable for myself. It's like, look, no, the doctors, even though they try their damnedest to take my money, they're not really concerned with my health. They're concerned with keeping me as a client and backing me up against a wall to take advantage of me. So it's my responsibility to take care of my health, to take care of my finances, to take care of my loved ones, my student, right? Like, as best I can. But if things go sideways, I need to take responsibility for my experience. I can't blame others. I need to be the one to take from my experience. But in the same token, the other side of the coin is true as well. When things are going right, you know, then I receive all the glory or whatever. But and then one other one is, why sharing the blame when we can share in the glory? So instead of trying to find a scapegoat and blame somebody, like, you know, President Trump, I can't even say that, but 45, I think his name is, whatever his name is. He was always trying to place blame. You know, he would never be accountable. I'm like, yo, you're the leader. Like, it was your choice. They're just doing what you told them to do, you know, so you got to be accountable. Anyway, that's neither here nor there. Okay, so begin by graphing the absolute value function, then use the transformation. So transformations, right? I think it was a total of 10 transformations. A brief synopsis of transformations. Generally, outside manipulations cause a vertical change and follow our intuition. Generally speaking, inside manipulations cause a horizontal change and are the reverse of our intuition, right? That's about the best way I could sum up transformations. Now, obviously, it's more nuanced than that. So absolute value, right? Okay. So now if we look at this, we have 3 transformations at play here. There's that +3 that's inside our basic function. And then we multiplied a negative on the outside of our basic function, and we added 7 on the outside. So we did 1 manipulation inside, 2 manipulations on the outside. The recommendation is, whenever we're doing multiple transformations in one go like this, the recommendation is to work your way from the inside to the out, right? So this is basically saying, start with a V at the origin. That +3 on the inside says to move left 3. We multiplied the outside by a negative. So it's like the Y's go from positive to negative. So we flip it top to bottom. And then we added 7 on the outside. So that means we move up by 7. Okay. So again, we start with the vertex at the origin. We went left 3, so it can't be B or C. And then we flipped it upside down. I think the only one that went left 3 and is upside down and up 7 is A. So I'm just going to go with A. Okay. Again, if anything is not clear, if you have questions, feel free to unmute yourself. Let me check on you guys in Zoom. Okay. Looking good, guys. Okay. So write the function whose graph is this, but is reflected over the X, right? So if you're flipping top to bottom, that means you're multiplying the outside of your basic function by a negative. So write the function whose graph is this. So it should be the same thing, but it should be a negative square root of X plus 1, right? That means we flipped it top to bottom and then we went up 1. Okay, I'm going to go with that. We could have made a mistake there, but I think that's what it is. Find the intervals over which the given function is increasing, decreasing, or constant, right? So if we think about this graph, right, the highest exponent is a 1. So that means that we're dealing with a line. We see that the y-intercept is -1. The slope is -2. So we have a diagonal line with the y-intercept of -1 and a negative slope. So that means as you trace it left to right, it's going to be going down. All right. So it's never increasing. The function is decreasing over the entire domain, which is the entire all rows. So we're going to say -infinity to infinity and beyond. Okay. All right. Constant is never a constant. So I think that's it for that one. Okay. So find a function f and g so that f composed g equals h, right? So again, we're back to composition of functions. Again, that symbol means the second function inside the first function, right? So for something like this, it's probably a good idea to identify your inside function first. So our inside function could be, let g be 3x plus 7 plus 6, right? Okay, so it looks like what, a, and then f of x to be absolute value. That looks good. So that way, when you do f composed g, your inside function is that 3x plus 6. We're going to go with that one. Okay, on to the next one. What's the time? Okay, yeah, that's fine. And if I notice any of that on the final, like any question that had you know, interactive figures, I'll just give people credit for those. I'm not gonna hold that against anyone. So I just got to get past these. We had quite a bit on this one. Okay, so use the graph to graph g. So okay, so this is the graph of f. So then g is, we do a +2 on the inside, right? So that's going to cause a horizontal change, and it's going to be the reverse of our intuition. So this means it should go to the left by 2. So the only one that went left by 2 is C. We're going to go with C. Go on to the next one. Okay. So we're given f and g, and then we're asked to find each of these. So f composed g, the second function inside the first, square root squared. Only thing here, sometimes the absolute value pops up. Okay. So if we do the second function, we might get this one a little bit off because of the absolute value. This is okay. Second function inside the first, all right? So the square root is going to be canceled. It's going to be 4 times 9 times x, so 36x. I'm just going to go with 36x. The domain, we're supposed to be doing this. Okay, so the inside function is square root, so that domain is 0 to infinity. The simplified, the domain is all reals. So then the intersection is going to be 0 to infinity. Okay, and square bracket 0. If anything is not clear, we can expand. Okay, for instance, if we tried to do a -1, we can't take the square root of a negative in the beginning, so we can't include that here. Now, when we do g compose f, okay, f is inside of g. I'm tempted to put absolute value. I'm really hesitant. I kind of want to do a quick search. I'm gonna just go with my intuition. I'm gonna put this one as absolute value. I'm not sure if it's the same. Let me see. I mean, I guess we can do the same. Let me just do the same thing. I'm really tempted because sometimes they accept absolute value and sometimes they don't. But I think they're trying to drive a point. Let me think about it. Give me a moment. And it's going to be the same domain. Can I just hit tab? No. What about this tab or shift tab? No. Okay, that's okay. And I think the domain is the same for the same reasons. We might get this one wrong. And I probably should be writing it out. F of f, f compose f. I just want to do a quick search. Give me just a second. square root of x squared. Absolute value. Absolute, there it is. No. Oh my goodness, I can't type today. Square root of x squared. Absolute value. Let's see. Why does where is it? Is a square root of x squared? I think that one should be absolute value, right? Absolute value, non-negative root, for instance. Because when you square it, it removes the chance of it being negative. So I think whenever the squared is on the inside, as in part B, I'm just not sure if that's what they want. Because I know it should be absolute value. I'm gonna put it. I'm just gonna try it. If we get it wrong, we get it wrong. But at least we can get to the bottom of it. I'm gonna put it as absolute value. It might mark it wrong. Let me see if I do this. Absolute value of x. Okay, we're just gonna go with that. Because basically what it is like it forces all, like sometimes negative solutions work. So then when you square it, it removes your chance, it removes the negatives. So like when you square it and then take the square root, it forces it into absolute value. It might mark this wrong, but I know that this is right. It just depends on like what they're looking for. This might be like out of the context or whatever. But you know, so there's a little bit of disclaimer there. F of f, right? So f inside of f, 16, 4 times 4 to the power of 3, 16 times 4 is 40 plus 24 is 64 x to the 4, right? I think it's 64. I feel like I should write that one out too. Yes, let's do 64x to the 4. Okay. Domain. It's like it's all reals, intersection all reals is going to be all reals. Parentheses, negative infinity to infinity. Okay. G compose G. Let's see. So the square root of 9 is 3. So that's 27. Well, you're going to have the square root of the square root of x. So that's like x to the half to the half. So then you would multiply. Is that the same as the fourth root? I think so. That's what I'm going to go with. I don't know if they want square root of square root or fourth root. Let me think about it. I'm going to put fourth root. So 9 times 3, 27 in root. Say if I do in root. What did I hit? Like this. Oh no. In root. There it is. Okay. I'm going to put fourth root of x. Okay. So or they might want the square root of the square root of x. But I think I'm going to go with this. It just depends. We're just kind of arguing notation. Come on. What's the time? We got a few minutes remaining. If I can get this cursor in this box, for some reason it won't let me. It's really temperamental. Okay, I'm going to go with that. The domain here. So 0 to infinity, intersection 0 to infinity. Yeah, I think it's just going to be 0 to infinity. So like this, 0, comma, infinity. I'm really curious about this one. This one is question 10, all right? So we're going to see about that one. I'm pretty sure we got some stuff wrong there, but let's keep going. Average rate of the function. Okay, so for our purposes, whenever you see average rate of change, all that is basically finding the slope between 2 points, right? So again, for our discussion, whenever you see average rate of change, that's just the slope between 2 points. So let G be this, find the average rate of change as x changes from -5 to 7, right? So slope, I'm going to just work here. I'll take some notes here. The slope is going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. All right, I'm just taking notes so you can see it, okay? So average rate of change is just a slope between 2 points, okay? X, y. So let's find y2 when x is 7. 49, let me see. Hey Siri, what's 2 times 7 minus 7?
2 times 7 minus 7 is 91.
91, okay. 91 minus, when x is 5, 25, 50, 43. So 43, and then down on the bottom, we're gonna say, it's basically 7 plus 5. Because it's 7 minus a negative 5, double negative becomes positive, okay? I'm just typing out the notes. So then this simplifies down to, if that were 50, that's 41, so 48 on top. And that's 12 on bottom. What is that, like 4? So
Yeah.
let's 4, right? Let's go with 4. Thank you, 4. Okay. Okay, let's do at least one more and then we'll call it a day. Fine, okay, difference quotient, right? So difference quotient is just an application of combining composition of functions or combining functions, right? Adding and subtracting functions. We kind of do need to write this one out. Yeah, let me write this one out. This will be the last one. And then we can see how do we do, especially that one. I think it was like number 10. I'm pretty sure we got something because it's like, I know it's supposed to be absolute value, but they might not want it as absolute value, right? Okay, let's delete, copy and delete. Let's hop over here. Let's paste the image. Come on, allow the paste. Okay, we're gonna work here. All right, so for the difference quotient, it's recommended to work each part separately. Let's do the first part. Let's do it in green, right? So let's go ahead and find f of x plus h. Okay. Oh, well, notice there's no x. I think it's going to be 0, right? Difference quotient is really, it's an application of the slope between 2 points, but f of x is a horizontal line here, right? F of x equals 8 is a flat horizontal line. And the slope of a horizontal line is 0. So there's nothing to calculate there. Find and simplify the difference quotient. Yeah, we're gonna say 0. So the slope there is essentially 0. Let's do, see if we get one more. We said that's it. Yeah, we need to get going. Let me submit this. That's fine. So let's see, how do we do? See if we can review. Number 10. I knew we got, it's the absolute value because I definitely included it and I probably should not have. Let's see. I think I just, 342. What did I do wrong? 36. Let me see. It's just because I didn't write it out. I should have written it out. G inside of F. Yeah, I forgot to square the 9, right? 9 squared is 81 times 4. I just did 9 times 4 instead of 81 times 4. So I think something similar happened for part B. And a lot of that was me rushing. I got it backwards, right? 9. Yeah, I should have just written it out. So we got the absolute value correct. I was so distracted by that. We should have written it out. But that's fine. You live and you learn, right? You can't win them all. But again, those errors came mostly because I didn't write it out. Now let's see what happened with question 3. Okay, I felt like that one was off. +1. So they wanted us to distribute the negative. So, okay, so what we did wrong, I think I flipped the base function instead of flipping that function. So that was I just interpreted it incorrectly, right? So for this one, I was just flipping, I wasn't manipulating the base function, which is just square root of x. They wanted me to flip the entire function. So what that means is I should have distributed the -1, right? That's where we got wrong there, okay? All right, so So because of stuff like this is why I allow unlimited attempts. You know, sometimes, and like sometimes, like I've had students where they take an exam, they were like, they'll ask me, well, can I get some credit for that? And I'll look at it. Sometimes I give credit. It just depends on how close they are. You know, if they just couldn't type it properly, it just depends, right? So I think for something like this, I would make the person go back and do it again because it was just wrong, right? If it's just wrong, then it's wrong. Okay, guys. I'm not sure if you have any questions. We're writing. Let me make it available. So when this bar finishes loading, you'll receive a copy of what you saw me writing. And if there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. See you for our Wednesday's class, the last class, guys. Take care. Peace.